Hello to everybody. Thanks, Pierluigi, for the introduction. My name is Luca Ollari. I'm a mechanical engineer. I am senior research and development manager. I'm here today to introduce our high pressure line 3A certified. First of all, some words about the 3A. 3A it's born in the United States. It's the first standard for the hygienic design of the equipment used in the dairy industry, and were introduced at the beginning of the last century and become known as 3A standards. So it's dedicated to the mission of advancing food safety through the hygienic equipment design. So, why Bardiani develop an high pressure valve through a certificate? Bardiani produce high pressure valve from more than 30 years, and a line that are able to work up to 150 bar. But in line with our commitment to continuous improvement and the need has arisen to further enhance our range of high pressure valve. The market is always seeking component in our case valves that increasingly high performing in terms of hygienic, cleanability and quality. So it borns from our customer needs, and that's the reason why we decide to develop a new version of our high pressure valve capable to obtain the 3A certification, and this to demonstrate the Bardiani commitment to comply to the most demanding international standard. Achieving this certification allow Bardiani to improve the hygienic design of the valve, to improve the cleanability of the valve, thanks to a in-deep study of the flow inside the valve body. So starting with the help of CFD software, we find the correct position, for example, of the shaft in open position, to be able to create the correct turbulence to clean properly all the surface in contact with the product. And at the same time, we reduce the pressure drop in the valve. All of this has contributed to improving the valve environment sustainability by reducing the use of water, the cleaning product, and also consequently lowering the energy consumption. So that's the main reason why we decide to make a step forward. The importance of the 3 certification and what kind of technical solution we adapt thanks to the standards to be able to redesign completely our valves, especially in the part in contact with the product, to be able to fulfill all the regulation. First of all, we change the internal design. As you can see in the picture on the right, we split in two. On the left, the old type, and on the right, the new type. But even if it's more than 10 years on the market. In the old type, we have a lot of that spot, that points that it's not so easy to clean, and where the product could remain, or where the bacteria can grow, because it's difficult with for the flow to reach this area and to clean properly. So we change the internal design, the radius, we avoid any kind of thread in direct contact of the product, and so we are able to completely redesign the inner space to improve the cleanability. Also the drainability, it's an important point because the valve must ensure complete drainage of fluid, avoiding stagnation that can compromise hygiene inside the valve and the product. Design that facilitate full evacuation of liquid without leaving residual contributes to more effective cleaning and easier maintenance, reducing the risk of bacterial growth inside of valve. Another important point is the surface finish, surface roughness control. This certification, the 3S certification, also require that the surface of the valve internal component is minimized. So basically, as a standard, we have less than 0.8 micron. So smooth surface prevent the accumulation of bacteria, of residue, ensuring also an easy cleaning. This is critical in sanitary application when even the small imperfection can harbor contaminant. And so all these design element enforced by the 3 certification ensure that the Bardiani high pressure valves are hygienically safe, easy to clean, and suitable for industry with a stringent sanitary requirement. So one of the most challenge point in during the develop of this line was the lip seal, because it's a dynamic seal, so it as in the picture, this is the lip seal. It's a dynamic seal because the shaft move up and down several times during the opening and closing process, and also this lip seal must resist up to 150 bar. And so from an hygienic point of view also, we need to have only one point of contact in the lower part, and a point of contact or a small surface of contact to ensure that we are able, if there is a leakage, to immediately left the product go outside of the valve and not remain trapped inside the groove of the lip seal. So for this kind of design of this special gasket, we search on the market one of important supplier that are able to follow us in this project from the beginning, offering superior sealing performance, offering also high quality material that fulfill all the European and American regulation like FDA, 3A, USP Class 6, and so on. And this is for increasing the durability because it's a dynamic seal, ensuring also the longevity of the gasket even under extreme condition, as in the high pressure process. Yeah, but for this kind of lip seal, we will talk again later with our special guest that will explain to you in detail the process of development of this kind of seal. So, why choose an high pressure valve 3A certified? Basically, there is several advantages to use a certified valve. Are mainly are because all the design are controlled by a third part verification. and this inspector from the 3A ensuring compliance with the international standards and improving increasing the trust in the product. So he check the quality of the material with the certificate, not only the material of the stainless steel, but also the material of the elastomer that we use in contact with the product. He check our quality program so that we are able to produce the valve always with the same quality and guaranteeing consistent product performance. And lastly, he control also our welded technique that are applied on our high pressure valve, ensuring strong and reliable joint that are important and critical for high pressure environment. And all these factors together ensure a superb valve solution because we produce all the part in contact with the product from a solid bar of stainless steel. And it's very important for the high pressure process. So now I left the stage to the next guest, Ms. Mark from Freudenberg Sealing Solution. Thank you to everybody.
Yeah, hello, welcome from my side. And at first, a really big thank to Bardiani to give me the opportunity to present some insights about the chef seal solution in this case. My name is Mark Boggasch, and I'm working for Freudenberg or with Freudenberg for 26 years now. So next slide. Okay. If you have a brief look at Freudenberg, we see a global company group with a high diversity, and it's still 100% family owned. And we have more than 50,000 employees worldwide. And if we now look to the Freudenberg sealing technology, it's a part of the group. It's one of the biggest divisions. And yes, I really like this slogan here on the right top, often invisible, always essential. And I think, you can imagine for most people, seal isn't really an important component, yes, but until it fails, and then it is. So in this context, I would say our passion is to develop robust seal solutions. And therefore, yes, I think we have fortunately really a great team of experts with a deep knowledge in material, product, and process technology. Because at the end, for sure, you need all these three aspects to produce and deliver really a well-performing seal. Next slide. Okay. One important aspect for sure, the material. Here we have a really wide range of high-performance materials for the food and beverage and the pharma business with all known and needed approvals. And I think a really big advantage for us is that we develop and mix our materials by our own. So yeah, if we see a need in the market or maybe coming out of a customer project, then we can develop a new material. In general, I would say out of the portfolio, the EBDM material is often preferred because of very good resistance in zip conditions and zip media. And yeah, but if you have some oily or fatty media in higher concentration in contact with the seal or with higher temperature, then you have to look for other options. And here we have our Fluoroprene XP material. It is an all-rounder and is coming with much better properties compared to a standard FKM, especially during the sterilization step with steam. Yes, now if you have a look on the global legislation landscape for the food contact materials, we see Yes, what do we see? We see it's complex, and I think yeah, it's more complex as it assumes is you could assume with this slide here, and you can fill easily a session with this topic. But briefly, I would say in the EU we have the legislation frame given by the 1935-2004, and for the plastics, then it's a bit easier, where you have the 10-20-11 to fulfill. For the plastic materials, for elastomers, it's more complicated. You have yet not specific measures defined by the EU, but you have national regulations like here BFR and RT and so on in the different countries. From the legal point of view, it's okay if you fulfill one of them, then you can deliver within the EU. But often customers are not satisfied with this solution, so they would like to have their fulfilled their national regulations. Yes, and if you look to the US, we have the US has the legislation are regulated by the FDA in general, and you have additional standards like the 3A sanitary or the NSF. It's more comparable with in Germany with the DIN ISO or with the Europe or the EH standards. So, but from the legislation side, you have the FDA, and in China you have the GB 4806 for general safety requirements and the GB 9685 for the positive list of materials. But its positive list, especially in this case, is very different compared to Europe and the US. So it's not easy to get material approval for the whole world. It's always a challenge. Okay, then besides to the compliance, for sure, we have another challenging factors in the food and beverage applications. For example, high temperatures, aggressive cleaning agents or media or abrasive contents like sugar. And really often is a problem for dynamic seals. We have a really poor lubrication situation for dynamic seals because you have not a nice gear oil or something. So this is something challenging for dynamic seals. Yeah. And at the end, finding the right material is always looking for the best compromise, taking all aspects in consideration. But at the end, what I mentioned, I think not only the material, but design and the production process are important as well. Okay, now coming to the Bardiani valve in detail. Here we had several boundary conditions and requirements to consider. At first, coming from the application itself, so we have a shaft seal with a dynamic movement of the shaft and the defined strokes, and we have this high pressure, which could cause some gap extrusion, and we have to consider friction and wear behavior. Then we had some limited material portfolio to consider because we need the 3A sanitary certification, for example. Then if you look to the design limitations, we had a defined design space. We had to consider hygienic design aspects. And very important as well, the assembly process of the seal into the existing housing. And last but not least, we have to produce it. So we have some requirements coming from the tool and production of the process. As mentioned already, okay, we had to consider, had to take the existing housing for the design. So we had no flexibility to adapt the groove dimensions here. On another aspect that Bardiani had some experience with an existing seal the experience was that the lifetime with this shape you see on the left here was not sufficient under high pressure, and the hygienic design aspects were not fulfilled, and there was some free or dead space in the shaft contact zone, and this has to be avoided. If we, there's a FST design now. You can describe maybe as written here, elastomer shaft seal combined with a PDFE support ring, and the PDFE support ring was integrated to avoid gap extrusion under high pressure. So it's already known. It's nothing new. Here it's shown by it's an application for an O-ring to avoid gap extrusion under high pressure for O-ring, or as other designs with integrated PDFE ring on the right top here, standard solutions. And the idea was to combine this PDFE support ring with a shaft seal, and with a high performance material like our ABDM 302 or XP43 with 3A certification. And for sure that the elastomer has to fulfill the sealing function, and has to be designed according to the hygienic design aspects. And you can imagine, I think, if you see this design, all components, the elastomer and PDFE, has really precisely molded and machined in the process to get everything handled here with tolerances and for proper function. This solution was, I think, really a big step compared to the initial seal design in lifetime in hygienic design. But after a while, we saw some potential for optimization regarding the lifetime, because under high pressure, we saw a hotspot here at the edge of the PDFE, and sometimes the seal lip had a crack here in this area. And with this background, then we machined a small radius on the PDFE ring to reduce this stress strain situation. And this was really sufficient modification to increase the lifetime on a really good level. What has this changed? The consequence, and the support ring has to be installed in a defined orientation. So because then otherwise it would not help if it's in the wrong direction. Okay, and then coming to the last slide, summarizing, as I would say, we developed together with Bardiani a unique customized premium sealing solution. It's extremely pressure resistant. The design is according to the hygienic design standards, no dead spaces, zip cleanable. And with the EBDM 302 and XP43, we have all two materials with all or proven materials with very excellent chemical and thermal resistance, very good mechanical properties, and the complete range of requested approvals. Yes, and at the end, I think we are very proud to have our seal in this really only hygienic pressure valve system with certification according 3A sanitary standard on the market. Yeah, I think this was my last slide, and I'm through with my session. Hopefully it was not too long.
Happy Thursday, happy Wednesday, everybody. I'm very happy to be here and to provide my contribution to the webinar. I mean, it's not easy to speak after engineer Luca Ollari and engineer Mark. So that's why I'm very excited to be here. So my name is Andrea Genitrini, and I'm the sales manager at Bardiani Valves Canada, the official distributor for Bardiani in North America. So today, my presentation will focus on several aspects of the high pressure valves. So my idea is to give you a perspective on what kind of model we have available for you, what are the general specifications of the valve, and I will try to show you a couple of example, like field example that I encountered during my experience. So if you look at my slide, on the left side, we have what we call it the standard BBZQ, which is the standard high pressure valve. In the middle, we have our BBYQ, which is a septic high pressure valve with the steam barrier. And on the very right side of my slide, we have the BBZQM, which is the manual high pressure valve. So before moving forward into the technical specification, I would like to make a small digression on the aseptic concept. So generally in the market, when we look at an aseptic solution, we have different solution available. One is the metallic bellow, another one could be a PTFE membrane, or could be a steam barrier. In the specific case of a high pressure valve, due to the high pressure that must be handled into the valve body, bellows and the PTFE membrane are not available because they will crack due to the excessive pressure of the product flowing into the valve body. So for this reason, when we approach an aseptic concept applied to an high pressure valve, the only solution is to have a steam barrier. Steam barrier, very simple concept, is a stainless steel metal ring which is located between the part in contact with the product and the outside and the shaft, with a continuous flow of steam minimum at 121 degrees Celsius. We are sure that there's a physical barrier between the product side and the external atmosphere. So let's now dig into the standard execution for our high pressure valves. Standard connections are, we start from the N25 and we go up to the N100. Those are dimensions, obviously, for the European market according to the DIN 11852. But of course, we have the same dimension expressed in from the N1 inch up to the N4 inch. For what concerns the gaskets material in contact with the product, we need to separate between the sealing gasket and the static rings. We said that high pressure valve works with a very high pressure product, and sometimes we get up to 150 bar, 100 bar. So you can imagine that the strength of the actuator in order to push the shaft in a closed position is very, very hard. So for this reason, the only two combination, the sealing combination available are PTFE or metal-to-metal seat. PTFE is a very hard material, but is still a plastic compound. For this reason, the maximum pressure allowed for PTFE usually is around 15 to 20 bar, depending on the size of the valve. Whatever the pressure is over 20-25 bar, then the only sealing solution is a metal-to-metal seal located between the body and the shaft. Different story for the static ring in contact with the product. I'm referring to lip seal or other ring to seal the body. In this case, Bardiani has a different option like EPDM, FKM, or HMBR. As we said before, in terms of pressure, we have a maximum nominal pressure of 150 bar for any valve with a diameter starting from the N25 up to the N80, the N1 inch, the N3 inches. And we decided to limit the maximum pressure allowed at 55 bar just for the high pressure valve with a diameter of 100 or 4 inches. In terms of connections, we always recommend to use welding ends. The reason behind this recommendation is that welding ends connection are clean. There are less point of contamination. They are like more hygienical. So welding connection are like going in the same direction of the 3A idea behind the high pressure valve range. One thing that I recommend you to keep in mind whenever approaching a high pressure valve is that the thickness of the welding ends are not the standard thickness that we are used to have with a low pressure valve. So from smaller diameter, we have a thickness of 2.5 millimeters, 3 millimeters for the N 2 inch and 65, or 5 millimeters for example, for sizes as the N 3 inches or the N 80. There's a limited number of options available for the high pressure valve, but they are very significant. Whenever there's a need of regulating a high pressure system, we can have an electropositioner mounted on top of an high pressure actuator. So we are able to regulate or adjust a flow based on a 4 to 20 milliampere signal coming from any device in the field. For example, we need to adjust a flow in terms of flow rate, or we need to adjust a temperature by closing or opening a little bit the valve. An electric positioner fitted on a high pressure valve could be a good solution. Along with an electropositioner, Bardiani is able to adapt the shape of the shaft, so we can adapt the profile, linear or equipercentage, in order to get the proper KV for a particular application. Another option is to use pressure regulator or a manometer. This device is always recommended whenever the high pressure valve is used as a pressure relief valve. So being the actuator a double acting actuator, that means air to open, air to close, having a pressure regulator, you can adjust the load on top of the valve, so I can set an opening pressure that release the overpressure into the pipelines. The next picture is the hydraulic damper. So the hydraulic damper is a special enclosed actuator equipped with a oil fluid. So it's used a lot whenever the high pressure moves too quickly due to the high pressures into the pipeline. So we can use this device in order to smooth the opening and the closing operation of high pressure valve. The last option is a twin stop actuator. Twin stop actuator is an auxiliary actuator which is placed on top of high pressure valve. is used to allow the high pressure valve to get into intermediate position. So the valve is not fully closed, it's just a little bit open. So it's used a lot whenever I need to keep a flow on a valve, but I don't want to keep the valve completely closed. So there's a minimum flow whenever there's a product that tend to solidify, or with whenever it stops, create problem. So I can keep the valve a little bit open using a twin stop actuator. So Bardiani is very famous for his capability of customize any valve. So of course, one of the most frequent customization is to create valve with special diameters. So of course we can have high pressure valve with smaller sizes, for example, the N10, 15 or 20, or the N 3/4 of an inch. As well, we can create even a bigger valve, for example, the N 125. We can also achieve special valve bodies in terms of design. So whenever customer has their own idea on, special valve body with a special size and shapes, usually we do a lot of special execution based on customer demands. As you can see in the picture, here we have sort of a customization of M8 LLL high pressure valve, which is a non-slamming divert high pressure in order to avoid any water hammer during the diverting operation. As I said before, shaft profiles can be changed according to special KV requirements, so linear or equipercentage. Surface finishing are always minimum 0.8 array for all the parts in contact with the product, but again, we can get any surface finish. Of course, we can supply certificates, electropolishing for the entire parts in contact with the product. I would like to get your attention on like two applications, steatite and cauterization. So those two are like intending as a process to treat mainly the shaft and the seat. The reason is that sometimes, due to high pressure, product with seats, product with small pieces can laminate, can erode the surface of the seat in the stainless steel. So this treatment, steatite and cauterizing, has the ability to increase the hardness of the seat, and the hardness can reach almost the same strength, superficial strength of a duplex steel. And of course, one of the another customization very usual for Bardiani is to instead of producing the valve in stainless steel 316L, to use different grade of stainless steel, for example, SAF, Astelloy, or any other material. So now part of my speech is to present you some application that we often encountered in field. Of course, there's just an example. I'm pretty sure that that you guys have seen different application of high pressure valve. So feel free to send me an email, send me a picture, let me aware of how you are using the high pressure valve in field. So the first application, which is the most common, is to use an high pressure valve as a pressure relief. What does it mean? You see the right picture. There's a low pump, which is able to generate a lot of pressure. I can use a high pressure valve in order to open a particular set point, able to recirculate the product back into the pump, avoiding to build up pressure or to damage other components downstream. You see on the left picture, there's a homogenizer. Homogenizer, per definition, sometimes they create a peak of high pressure. So I can use again an high pressure valve to normalize the pressure coming out from the homogenizer. Here we have an example which probably is one of the most common, which is the shut-off, used as to cut a high-pressure stream of products into the valve. One of the application I went through was to shut off a stream of water to cool down a cutting system of a stainless steel bar. 150 bar, those kind of valve are pretty good, pretty able to shut off, to cut any flow at any given high pressure. Diver valve, this is another classical example. This is a cooling system of margarine product. The cooling sometimes is very tricky because the product is hot. So hot products has a very good viscosity and density, but during the cooling process, then the viscosity and the density will go up because the product is getting is colder. So sometimes we use those high pressure diverting valve in order to be able to increase the pressure and complete the entire cooling steps of the product. So those were just a couple of examples of how to, use high pressure valve. So my contribution now ends here, and I will invite Mark and Luca to join me on the webinar. So we open mic for questions. I think this Mark.
The first one was about vinegar concentration. To be honest, I think we have a tool, or where we can look about resistance of material, and I would have to check in detail. So it would not be serious just to say something. So if it's something we have to clarify about resistance of material, it's not a problem to send all the conditions. It's the concentration, material, and the temperature, and everything together. Then we suggest the material. PFAS-free material, it's for me. Okay, yeah. Okay, it's at the moment, I think nobody can say if the EU ban will come or not, and there are different opinions. So I don't know. But if it comes, for sure, it has a really big impact for the sealing business. So far, I would say if you have a fluorinated material today in your application, it is the best background. Maybe it needs a media resistance, the high temperature resistance, or you need, in case of PDFE, low friction. And so far, there is not a material where you can say you can replace it one by one. So I mean, we have, and this is done in different projects with our customers, look for especially what we can do in different applications to replace the fluorinated material, but this has to be done really in detail and to take into account all requirements for the seal. So it's possible sometimes, but we have not, and I can't see that it will come soon, a one-to-one replacement for PFAS material.
Okay, it's my turn. I think I see some question about the possibility to interchange, to change from the old line to the new line. Yes, it's possible because we keep the same distance between axes. So from a dimensional point of view regarding the connection, you are able to change, to remove the old valve and to put the new one. Another question from Lohani. High pressure valves are single seat type or mixed proof? No, high pressure valve are only single seat valve right now. We don't know in the future. And I see another question. Do you also have anti-hammer? Yes, as explained my colleague Andrea, we have a hydraulic damper that help to avoid water hammer during the closing opening operation of the high pressure valve. Do you manufacture, an answer from Carlos, do you manufacture valve body from mold? No, absolutely not. We produce all the part in contact with the product from a solid bar of stainless steel.
Okay, this is for me. Okay. Yes, it's a good question. I think you look or you see this rectangular free space and at the back of the seal. So we have some free space or dead space. But at the end, you need for elastomer seals, you need some room for expansion because you have higher thermal expansion coefficient and you have some tolerances to handle. So you need some space. And important is that this area is really far away from the media. So it's can't be filled by media from the media side. So and it's not. Sometimes it's possible to have the expansion area in the direction of the media, but in general, that's not so. So you have to design somewhere a space for the expansion of the elastomer.
Another question, how long did it, from Elizabeth, take for Bardiani valve to pass the 3 certification? It takes approximately 2 years, from the beginning of the project, design of the internal part, the part in contact with the product, and the collaboration also with the Freudenberg to find a good design for the lip seal, if I remember correctly, approximately 2 years. Okay, that's all. Thank you so much for everybody to be here. It's a pleasure to talk about our high pressure line. Also, big thanks also to Mark to support us not only in this webinar but also for the develop of the lip seal that is very important in our high pressure valves. Thanks so much to everybody. See you soon.
Bye.